Okay, so the purpose of this video is to introduce spectroscopy, so I'm going to call this Spectroscopy 01. This is real, or even maybe 00, right? This is just to motivate why we even are doing videos for spectroscopy. And I'm gonna demonstrate what I think you ought to be doing as a student, okay? So there are 5 kinds of spectroscopy, and we're going to talk about what each one is for. 5 kinds in most organic textbooks, and of course this is in the context of organic chemistry, but it can be used for other things as well. So first of all, there's mass spectrometry, which we oftentimes call mass spec or MS, and we'll talk in a second about what's the main take-home message for that. There's infrared spectroscopy, which is we oftentimes call it IR. And there is, which I'm going to say mass spec, IR. There's UV vis spectroscopy, which is absorption and transmission of light in the ultraviolet range or the visible range. There's proton NMR spectroscopy, which is nuclear magnetic resonance, HNMR for hydrogen NMR, proton NMR. It's not deuterium NMR, so it's HNMR. And finally, carbon-13 NMR, which is the nuclear magnetic resonance of the flipping of carbon-13 nuclei. So, here's the thing, I'm going to say this for my classes, and I might even try to sell other professors and other students on it, that we're not going to talk about in these videos, we're not going to talk about UV vis spectroscopy. It's for reasons which I'll describe later. And we're not going to talk about carbon-13 NMR for reasons which I'll describe right now. If you really understand proton NMR, I'm going to claim carbon-13 NMR sort of a natural progression from proton NMR. So we're going to really focus on these videos and in my class on mass spec, IR, and proton NMR. These 3. And that's a big relief. It significantly, as you can see, reduces the scope of what we need to cover. Okay, so first of all, mass spec. What's the main take-home message for mass spec? What you may want to do at this point is you may want to pause the video and go look at your textbook and see if you might have a chapter or a half a chapter on mass spec, and you may want to see if you can tell what's the main simple take-home message. You should always be doing that when you're studying all of your topics, especially in organic chemistry. You should be thinking about what's the simple here, okay? So the main take-home message for mass spec, I know other organic chemists are going to disagree with me on this, you know, but I'm right. The main take-home message for mass spec is, I'm going to pull that sheet down, is molecular weight, okay, or formula weight. This will make more sense in a little bit when we start talking about the why and the how. What's the main take-home message for infrared spectroscopy? So you may have paused this video to figure it out, and hopefully you did. This will make a lot more sense to you if you're thinking ahead. Functional groups is the main take-home message for that. As I said, I'm going to skip UV vis. It's got to do with double bonds and conjugation. And the main take-home message for proton NMR is connectivity. And as I said, the carbon-13 NMR is also connectivity. All right, so the main thing you need to do, and when I'm talking about this in class, I always say this is my first lecture, is just what's the main take-home message for this. Really important for you to think about this. And the reason I say that is because a lot of times students will put hours and hours and hours of work into spectroscopy and not really even get what they're doing. Okay, so if you can appreciate the main take-home message, it'll be a lot easier for you to appreciate the nuance. Okay, so next thing we're going to do is I'm going to go through and exemplify each of these. But I'm going to give you, first of all, I'm going to talk about some primary advice, which I realize I'm not showing you all of it right now. And then I'm going to conclude this video with some final advice, which I'm not going to tell you what it is right now. Okay, so first of all, definitions, then some examples, then primary advice, and then the final advice. Actually, let me give you this to you now. So my primary advice for you is to watch these videos. And this is, I think, the only topic in all of organic chemistry where I say that these videos are the ones you need to watch. I will most often say that there are better videos out there, Khan Academy and Mastering Organic. There's some really, really good ones out there, but I haven't found any that approach this in the level of simplicity in which I think it needs to be approached. So watch these videos first to get a big picture idea. You are looking for the big picture idea of how to use spectroscopy. Far more important, the big picture, than the details. And we'll get the details in time. And I know a lot of times organic students have achieved a lot of success in other courses. And so you sort of come into this class being a master of nuance. And it takes a great discipline to look for the big picture in this course, and I think you need to do it. All right, second piece of my primary advice is to practice some simple spectra. Now, what are simple spectra? We'll talk about that in my final advice, which really has to do with this. Practice simple spectra. You must practice simple spectra. And in order to appreciate the big picture. And then finally, and last, is you need to do the assigned problems. And you should do this last, all right? Because the assigned problems are all about primarily about nuance. There are some simple ones in there, but mostly they're about the difficult stuff. And if you can appreciate the big picture, the difficult stuff fits a lot nicer in your head. And then the last thing you should do really is read the textbook. Okay, so that's my primary advice. Now let's go back here and talk about mass spec, molecular weight. When I say the molecular weight, of course, what could I be talking about? All right, so let's talk about a couple of compounds that differ in molecular weight. First of all, cyclohexane and cyclopentane have the same empirical formula, right? It's CH2. That's the empirical formula for both of these. And they have the same connectivity. It's a CH2, bonded to a CH2, bonded to a CH2, right? Bonded to a CH2, agreed? And I guess in cyclopentane's case, it's bonded to a CH2, bonded to a CH2. Cyclohexane is just the same thing with another methylene carbon intercalated in there. Okay? And this has exactly the same molecular weight, or I should say rather the same empirical formula yet, right? 1, 2, 3, 4. So it's C4H3 plus 2 plus 2 plus 1 is 8. C4H, how do you spell C4H8? Like that, I guess. Okay, so all three of these have exactly the same empirical formula. So if we analyze them with combustion analysis, we would find that we had an empirical formula of CH2. But that wouldn't tell us what the molecular weight was, right? Of course, there's other ways to get the molecular weight, but mass spec is a super one, and it's the main take-home message of mass spec. Mass spec, molecular weight. Okay? Infrared spectroscopy. Functional groups. Alright, so when we talk about functional groups, I'm talking about alkanes, alkynes, alcohols, alkyl halides, aldehydes, and so on, right? Okay, so these are functional groups. Let's talk about two compounds that have the same functional groups, but different molecular weight. For example, 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. That's hexane. Or here's 2-methylpropane or cyclohexane, right? These all have exactly the same functional group, but different molecular weights and also different connectivities, right? So here's some examples of alkanes. Here's some examples of alkynes, or rather alkenes. Here's some examples of alkynes, and so on. These are things that are memorized in different sections of your course, but we use infrared spectroscopy to differentiate between functional groups. So an example of that would be two compounds which have the same molecular weight, right, but different functional groups, right? Here's an ether, and here's an alcohol, and we would be able to tell the difference with infrared spectroscopy. We'll talk more in a few minutes about exactly how. Right now, again, we're looking for the big picture, right? Okay, and then finally, connectivity. So, two structures that differ in different, like that's a word, which of course, I guess if we picked it apart, each little syllable would make sense, but what do we mean by connectivity? Well, here's a good example of connectivity. 2-methylpropane and butane, right? They have exactly the same molecular weight. They have exactly the same functional groups. They're both alkanes, or I should say, in this case, absence of functional groups, right? And but they differ in the way that they're connected. And so, proton NMR would be a super technique to differentiate between those. Here's another example. Cyclohexane and 1-methyl-cyclopentane, right? They have exactly the same molecular weight, but different connectivities. And same functional groups also, right? So that's what I mean by connectivity. All right, let's go to the final advice now, what you need to do in spectroscopy. And I'm going to go over this and over it and over it. Think of two compounds whose structures differ only in, for example, molecular weight. And after you've thought of those two compounds, my example that I gave to you in this earlier picture was cyclohexane and cyclopentane, right? Think of those two compounds and then Google their respective spectra. So we Google their mass specs and we find and we look at how they differ. I'll do those in some follow-up videos. I'll give you some specific examples, although I'm telling you this is the only advice you really need, because you could do this yourself. You understand, at this point you feel probably like you don't fully appreciate what you'd be even Googling, but you would simply Google mass spec cyclohexane, mass spec cyclopentane, okay, and see what you find, okay? And then the final step of my final advice is to confirm for yourself what they or how, or rather that they do indeed differ, and see how they differ. So that's my final advice. Number one, think of two compounds whose structures differ only in the feature that you're talking about, right? Differ only in functional groups. So you might want to take your where's that picture here? You might want to take your ether, dimethyl ether, or your alcohol, and Google their functional group, their IR spectrum, right? Google them and see how they differ. And if you do that enough times, then you will gain I think a real deep understanding of spectroscopy. Okay, so this is the introductory video, and then I'm going to go through now and make some more videos. I've made some already for mass spec, some for infrared spectroscopy, and some for HNMR. Okay, good luck.